Hello, ladies and gentlemen. Thank you for tuning into this Geometry Honors screencast lesson on the introductory lesson for solid geometry. Geometric solids are three-dimensional figures, not two-dimensional or flat the way we've been looking at them so far this year. I know you covered a lot of this in middle school, but we're going to go through this again just to level set everybody. All right, the figures we'll be talking about are a sphere, a cube, a cylinder, a rectangular prism, a pyramid, and a cone. So let's take a look at prisms. Prisms has two parallel faces called bases, typically the top and bottom. In a triangular prism, like here on the left, the top and bottom are triangles. Okay. The lateral faces are rectangles in a right prism. If it's a cube, all faces are congruent squares. Okay. So the lateral faces are what you can see when you're looking straight at it without the top and bottom. Okay. So think of lateral as the faces but no bases. The total surface area would be all the faces. Okay. The volume of a prism is the area of the bottom, the area of the base, the capital B, times the height. Okay. You'll see that except for the sphere, we start out the formula for all the volumes of all the geometric solids as the area of the base. The surface area of a prism is the sum of all the areas of all the faces. So if it's a rectangular prism, you'll have 6 sides to add up. Okay, every 2 will be congruent. So, and on a cube, you'll be figuring out the area of one side and multiplying by 6. Okay. So pyramids. The lateral edges are congruent. Okay, that's these here, lateral edges. We're dealing with regular pyramids, so the bottoms are all squares. So if we look at what a pyramid is comprised of, it's a square base and 4 congruent isosceles triangles around that make up the sides. So the volume, again, the area of the base, the bottom, times a third times the height. The height is the perpendicular distance from the point to the middle of the base. Okay, that's important because we'll be looking at problems where you need to find this. Let me get a pen here. You need to find this dimension right here. If I can draw it down. It's a little sloppy, but see this line here? That's the altitude of the triangle going down the face of the pyramid. Okay, and if you look at this, it forms a right triangle because the altitude from the point down is perpendicular. So we'll be looking at Pythagorean theorem problems to do with that. So that's the volume of the pyramid, 1/3 the area of the bottom times the height. The surface area is the area of the bottom, the base, plus the areas of the 4 congruent triangles. They're isosceles triangles that are the lateral faces. A cylinder. Bases are congruent. The bases of a cylinder are circles. The lateral area is the altitude times the circumference of the base. Because when we look at this lateral area forms the upright piece of the base. So if we look at what a cylinder might look like, you have the top and the bottom and this. So this lateral area, when you open it up, is a rectangle. Okay. So the volume of a cylinder, pi r squared, which is the area of the bottom, times the height. The lateral area of a cylinder is 2 pi r h. Now if you look at this, the circumference of this base is this distance here, which is pi times diameter, right? That's circumference. But diameter is twice the radius. So that's why we refer to this as 2 pi r h. Now the surface area, let me get a different color pen. Total surface area of a cylinder is 2 pi r squared plus 2 pi RH, which is the lateral area. So that's the entire surface area of a cylinder. It's the circular top and bottom plus the lateral area. Again, if you need to pause this to catch up and take notes, please do. So let's look at a cone. Cone is a very similar formula for the area as it is to a pyramid. So on a cone, you have the height, the altitude perpendicular from the point to the center of the circular base. Then you have the radius of the base. And this here along the side is called the slant height. You need that for lateral area of a cone. So let's look at the volume. It's pi r squared, the area of the bottom, times the third times the height. So the lateral area is equal to 1/2 the product of the slant height and the circumference of the base. So the lateral area is the slant height times pi times radius. Okay? S, you have to remember in this case, is the slant height. It's this right here. Okay? Spheres. Think of a basketball, a baseball, a softball, a sphere. The volume of a sphere is 4/3 pi r cubed. Okay? Pi r cubed here. The surface area is 4 pi r squared. Okay? The great circle, a great circle, is the largest circle that can be drawn on a sphere. On the Earth, the great circle is the equator. That is the widest part. Okay? It's the biggest circumference circle you can draw. So, what happens when a plane, a flat surface, intersects a sphere? Well, when a plane slices through a sphere, you get a circle. Right? You cut it and you take it off, and it's a circle. So if two planes are equidistant from the center of the sphere and they intersect the sphere, then those circles are congruent. Those circles are congruent. You need to remember that. Okay? So we can reverse that. If two planes have intersected a sphere and created congruent circles, then you know that those two planes are equidistant from the center of the sphere. All right, so let's look at some example problems. Find the volume of the following: a cube with the side length of 9 feet. So it's 9, 9, and 9. So the volume would be 9 cubed, which would be 729 cubic feet cubed. Okay. Rectangular prism. I didn't draw you one. So it always helps to draw out what you're looking for. Don't bother trying to draw it to scale, because you'll notice I'm not drawing it to scale because I can't. I also can't draw very well, but that's okay. Length is 9, width of 6, height of 11. Volume is equal to the area of the bottom, 9 times 6 times 11, high. So it's 594 cubic centimeters or centimeters cubed. Okay. Pyramid has a height of 9, and the length of the side of the bottom of the base is 10. So always start out writing the area formula. 1/3 the area of the base times the height. 1/3 times the area of the bottom, 10 squared, it's a square, times the height of 9. So it's 1/3 times 900. So the volume of that pyramid is 300 inches cubed, or cubic inches. Okay? Let's look at a cylinder. On the cylinder, the radius is given as 3. Write that down off on the side somewhere. Height is 5, okay? You have to be careful. On some of these problems, you'll be given the diameter of the circular base. You have to remember to divide it by 2 to put it in the formula, okay? So volume is equal to pi r squared times the height. Volume is equal to pi times 3 squared times 5. So this is now a calculated problem. Pi times 3 squared times 5 rounded to the nearest hundredth gives you 141.37 centimeters. Okay. Again, pause the video if you need to. Okay. Last one we're going to look at today, and then the lesson is over. The volume of the cube. Now this dimension here, that's the diameter. So if diameter equals 8, radius, excuse me. Let me erase that. Radius equals 4. So the volume is 1/3 times the area of the bottom of the base, pi r squared, times the height. 1/3 times pi times 4 squared times 12. And this is at this point, this is now a calculated problem. So the volume, you round it to the nearest cubic inch. Okay, you have to be careful. You have to pay attention to how the answer needs to be expressed. 201 cubic inches, or you could write inches cubed. Okay. So that's how you can express cubic inches or inches cubed. Same thing. Okay. If you notice, I was using them interchangeably. So you have the 6 basic geometric solids that we'll be working with. Review the screencast before class, because when we get into class, we'll be ready to start working right away. Thank you for tuning into this lesson on Honors Geometry, Introduction to Geometric Solids.